Okay, so far we've had a look at our giant ionic structures and our giant covalent structures. So we're moving on to the other type of covalent structure, our simple molecular. And these are going to be the sorts of covalent things you're more familiar with from having drawn the dot and cross diagrams, because they are distinctly more like those diagrams than the diamond or the graphite that we've looked at previously. Last video will be on metallic, and then we'll summarize. So again, remember, the structure of the substance affects only its physical properties, not its chemical properties. So simple molecular substances, they're things like carbon dioxide, water, methane, oxygen gas, all the things that you're used to talking about. And we call them molecules because they are one discrete unit made of atoms with covalent bonds. So in this case, we have our oxygen atom, our two hydrogen atoms, the covalent bonds in between, and we would call the whole part a molecule. And within talking about simple molecular structures, you use the word molecule all the time. So molecules have two types of interaction going on. So between the atoms, so within the molecule, are very strong covalent bonds, the same as we had in our giant covalent structures. So these bonds are really, really hard to break. The atoms do not come apart from one another easily. However, between the molecules, there's a weak force, not a bond, just a force that we call an intermolecular force, between molecular molecules, so a force between molecules that is quite weak and is very, very easy to break. And this is the force that we're talking about when we're looking at physical properties of simple covalent, simple molecular things. So what does this mean? Well, it means that most simple molecular substances are gases or liquids at room temperature. We need really, really low temperatures for those weak intermolecular forces to keep the molecules stuck together. So it's very rare to have a simple covalent thing that is a solid at most temperatures, because there is enough energy at room temperature to break apart molecules. And we can have a quick look what I mean by this. So I have lots of little simple molecular things. So we have like an oxygen gas, some carbon dioxide gas. Here's a model of carbon dioxide. Got some nitrogen. And as you can see, they're all discrete little units. They're molecules. And between them, they have very strong covalent bonds. So these are not going to break easily. You'd be destroying the chemical if you did break them, because you'd be pulling, for example, in the ammonia, you'd be pulling the hydrogens off the nitrogen. It wouldn't be ammonia anymore. But because they're little discrete units, they're very easy to separate from one another. So if I take water as an example. So here I have my glass full of water molecules. This is what it would look like if there was really water in there. Hundreds of billions of billions of billions of water molecules, all in the glass. Now, when we start to heat this up, we're not going to be breaking those strong covalent bonds. We don't need to get it to turn into a gas, because we can get each molecule to separate off individually. We don't need to break apart all of those bonds like we did with our ionic lattices and our giant covalent lattices, because it's not an infinitely big thing anymore. It's little discrete units. So all we have to do is put in enough energy that one molecule can break away. And because there's only the weak intermolecular force, it's very easy to break away a water molecule and turn it into a gas. So each of our water molecules can come away quite easily and separately, but I wouldn't be able to put in enough energy to break the bonds. That would be destroying the molecule. It wouldn't be water anymore. I'd be turning it back into hydrogen and oxygen. So because we have that weak intermolecular force, it's pretty easy to separate them out and get them to oil. So what does this mean for our physical properties? So if we think about the fact that we need a low temperature to keep them solid because of those weak intermolecular forces, it seems pretty obvious that that means they must have low melting and boiling points. We need very little energy to pull apart that weak force and separate the molecules out from one another. So we've got some examples of some simple covalent compounds down here. If we look at our melting and boiling points, for the vast majority of them, their gas is already at room temperature because there is enough energy at 25 degrees to keep those molecules apart from one another to stop them interacting. And the two examples, solid oxygen needs to be at minus 240 degrees. The temperature can only go down to minus 273 in a little bit. So you need to be very, very cold to get those oxygen molecules to stick together. So simple molecular substances will have low melting and boiling points. Also, because the bonds between the molecules are weak, they're pretty soft when they're solid. It's pretty easy to pour water. You can crunch ice much easier than you could crunch diamond, for example. Your teeth would break if you did it with diamond. And also, the molecules are not charged. We've only got atoms in there. The electrons are trapped in the bonds, so they do not conduct electricity when solid, liquids, or gas. So all simple molecular substances do not conduct electricity. So in summary, we had our ions for our ionic bonding, where we would talk about the ions. We would have atoms joined into giant molecules for our giant diamonds, graphites. Remember, graphite is our special case to learn. We have our simple moleculars, which are usually gases and only contain molecules. So we would use the word molecules a lot when we're talking about them. And in terms of their physical properties, our simple molecular that we've just looked at will have a low melting and boiling point and will be pretty soft when they're solid because the bonds between the molecules are very, very weak. There's only that weak intermolecular force that we have to overcome. So it needs very little energy, and they never conduct electricity because there are no charges on the molecules. They're unable to conduct the electricity. So hopefully we are good with simple molecular substances.